Dr. Gregory Kelly, so nice to speak to you again. I love talking about this topic, how we can age well and how there are such constructive things that we can do to actually facilitate this process. And you're an expert when it comes to senescence and longevity. And so welcome. And I can't wait to dive into this topic.
Yeah, it's such an interesting topic. The whole idea of senescent cells is such a new thing in healthcare. It would have been an afterthought even 10 or 15 years ago, where now you're definitely shocked with how much research is going in. And sometimes I think of, with what I know now, what is likely to be even more interesting, or something that we're more excited about 10 years from now, when I think senescent cells would be that for our listeners. So I'm thrilled to get to share what I know about the topic with you and your listeners today.
Oh, that's amazing. Well, let's start with senescence, and then please don't let us forget what you think is going to be, what's going to happen in the next 10 years. I'm very interested to hear that as well. So
Sure.
Can you just define senescence and aging and all these things, and why should people care about this?
Yeah, so senescence is the same root that gives us our word senile. So wrapped up in senescence is the idea of aging. In the current paradigm of aging, there's something called the hallmarks of aging. And what hallmarks are is, think of it as characteristics or behaviors. And what scientists have found is that in organisms, whether they're mice, rats, primate monkeys, humans, there's certain characteristics that we all have in common. And these are really cellular or system characteristics. And one of those is that's something called cellular senescence. So that in a sense, you can think of it as there's a subtype of cells that become almost prematurely aged in our tissues. And if they accumulate high amounts, they cause our organs, tissues, our brain, because I know you're very interested in the brain, to struggle to perform well. And so many of the challenges that we experience as we get older, there's at least some contribution from these things called senescent cells. So, and just to, I guess the analogy I like to use for listeners that might not be as scientific. So we'll start you have healthy cells and stress cells. Just think of those two categories. And senescent cells would be a type of stress cell that have been so stressed out that they're not allowed to make copies of themselves anymore. And the analogy that I used at one point for our head of marketing, who's a gardener, was to say, all right, like think of the plants that you're growing in your garden. There's, plants that all of the leaves, vibrant, vital, every leaf, green, doing really well. And then there's some plants that occasionally you'll see a yellow leaf pop up, right? And that ideally the yellow leaf should then just fall off the plant and be recycled in the soil and reused. Once in a while, yellow leaves start to accumulate. A couple yellow leaves beget more yellow leaves, right? They kind of spread that yellowness and that dysfunction. And if you don't prune them away, the whole plant can struggle. And so the big picture, when you think of senescent cells, all science aside, is just imagine that our tissues and organs can have the equivalent of these yellowing leaves that ideally should fall off. That's a term in Greek called apoptosis, but it comes from that idea of fruit or leaves falling off a plant. And that if they kind of stick in our tissues, then they can cause more cells to become the equivalent of yellowing leaves. And just like with a plant that would struggle if, more and more of the leaves become yellow, that's what happens in our tissues as senescent cells accumulate.
I love that analogy, because then what we ideally need to do is to make sure those yellow leaves drop off the plant, not stay on the plant. And that's the apoptosis that you spoke about. And then there's also the concept of autophagy. Can you talk about that as well, in terms of, now that you've mentioned apoptosis? And I love the analogy. It's so easy to visualize it.
Yeah. So I usually like to set up the table with just thinking about stress in general. So at a whole body level, right? We know what things that stress us, but certain things stress our cells as well. And when cells are stressed, they're going to have a range of menu options to choose from. And so if it's manageable stress, what they'll do is try to become more resilient. They'll do things like make more glutathione or upregulate other antioxidant defenses, things that, I was stressed, I might be stressed in the future, I'll be better prepared. But if stress is more than that, they'll probably take some damage. And one of the things that gets damaged within cells are proteins or organelles. And autophagy is a software program, so to speak, like a program cells run to essentially recycle those damaged proteins or organelles so they can be those, I guess the parts of them could be put back to better use. So the way to think of autophagy as something that would help prevent a cell from becoming senescent. But once a cell has taken on so much stress that the damage isn't repairable, that's when it would become senescent. Because we don't want to make copies of a cell that is that damaged or that stressed. And so when you think of like the hierarchy, that's a useful way to think about it, that the first response is, become more resilient. The second response is to repair damage. If the damage is too much, it's okay, let's freeze that cell so it doesn't make more copies. And then ideally, that cell should go through apoptosis. And the way usually I would describe it is think of there being transient senescent cells and lingering ones. So the transient ones are like the yellow leaves that fall off the plant. The lingering ones are like ones that stay stuck on. And it's these lingering ones that become challenging with aging because they've figured out a way to avoid apoptosis and just linger perpetually on the fundamentally like the plant. And so, the idea we'll eventually get to later in this talk will be what's called senolytics, which I think of as the gardener that comes in periodically and prunes the yellow leaves away.
I love that. So if we keep those lingering yellow leaves, that's what's going to accelerate aging and disease processes.
Yeah. So the idea of senescence goes back to the early 60s and work in growing cells in culture. And at one point it was thought that cells were immortal, that they would just live in that petri dish forever and ever as long as you gave them the environment and the food they needed. And in 1961, it was discovered that no, they would replicate only so many times before they would stop replicating and become what is now known as senescent. And so from the early days, there was this idea that, cellular senescence seems to have something to do with aging. And it turned out what that would be now called is replicative senescence, which is the idea of telomeres. If telomeres become too short, a cell won't make new copies. It will become senescent. So that's a type of senescence. But then over time, what scientists found is that what they would label as premature stress-induced senescence, that even if telomere length is perfect, right, there's many more potential copies that could be made. If things were done to really stress those cells out in that culture medium where they were growing, whether that was radiation or things with nutrition or you name it, then a cell would become senescent way in advance. And the lingering ones that I think are the problem with aging, I think mostly it's the stress-induced premature senescence that is causing, those to begin to become senescent. And then the other thing that occurs, just like with a yellow leaf on a plant. So one of the challenges with yellow leaves on a plant is they attract stressors, right? Like maybe insects and other things that can then cause healthy leaves to become yellow. And senescent cells in our tissues do something similar. It's sometimes called the bystander effect, but the big picture is they secrete things to the environment surrounding them and convince healthy cells to become senescent. So that combination of, making new senescent cells and the senescent cells figuring out ways to linger and not going through that process of apoptosis means that over time we accumulate more and more.
Oh, it's fascinating. And just if you think of it, cells, we talk about a cell and people may be thinking, well, what's it got to do with me? What's a cell got to do with you? Well, your cells make your organs and your organs make your systems and your systems make you, your brain and your body, and your mind's got to work through that. So, if it's working through senescent cells or cells that are not healthy, that's it's you, your whole being that gets affected in that way. And then you also mentioned about the stress factor being one of the main issues. And I'm so glad you mentioned that, because on this podcast, as you know, we talk so much about managing toxic stress and the impact that it has on the whole mind, brain and body psychoneurobiological network. So I'm so glad you mentioned that. And you said that's one of the main factors that is causing those lingering yellow leaves to hang on to your cells and not fall off like they should do. So yeah, this is very, very interesting. I mean, I'm fascinated with anything scientific, and you explained that beautifully.
Oh, thank you. Well, I think, the aging field I think if we went back 10, 15 years ago, telomeres were thought much more as a causative factor, where I think now by some of the smartest people, they would think they're at most a minor player. But I do think that idea of stress-induced premature senescence is a main reason that we accumulate these yellow leaves. And another reason is the backup plan for getting rid of stress cells is always our immune system. So part of its job is to find markers on outsides of cells that would make it appear to the immune system that cell is stressed, no matter what caused the stress, and then devour those cells to eliminate them. And you would be aware that as we get older, our immune system also struggles in identifying both healthy cells and stress cells, and so it just misses more over time. So that also contributes, and it's one of the reasons that the idea of senolytics, to me, I think is something that we'll be talking and learning more and more about over the next decade, because if these things are accumulating, these yellowing leaves, the senescent cells, if our immune system's not finding them, then our tissues and organs and our whole body needs a backup plan. It needs help. And that's the idea behind senolytics.
Oh, wow. Okay. Well, let's transition to that. But before you do, I'm glad you mentioned telomeres, because in the part of our clinical trials, we've also been looking at telomeres. And as you know, the idea was that they take quite a long time to change, and, the sort of exercise and that sort of thing. But we found in cycles of 9 weeks of managing stress, specifically managing the stress that comes, or toxic stress from whatever life events, whether it's big, small, makes a massive difference to telomere length and health of the telomeres, and therefore the cells and everything. So we're speaking, I love that you brought this up, because it's very real. We've seen in our work that this is a very real thing. Now let's transition over to senolytics, because as people are listening, they want to know what they can do. And this is where senolytics step into this gap, basically. Yeah.
So before we jump into that, just maybe like a other quick history. So I mentioned that senescent cells had been known about for a long time, but it was around 2010 that researchers genetically designed some animals so they would not produce senescent cells.
Wow.
And what they found is they aged just marvelously well compared to regular animals that could make senescent cells. So that was like, wow, okay, these maybe, we thought these were important, and maybe they're even more important than we thought. But, obviously we can't genetically modify, humans like you and I, right? Like, so, what's the solution? And so around 2015, a group of researchers at Mayo Clinic and Scripps Institute of Aging published a paper. And what they had done is they said, okay, well, it seems like the common thread in these lingering senescent cells is that they figured out ways to avoid going through apoptosis. And we know, because there's been a lot of work done in that area, that there's certain mechanisms within inside cells that either enhance going through apoptosis or allow cells to resist it. So let's look at compounds that have been studied that can help correct those mechanisms to overcome apoptosis resistance. And so what they published in the paper was they found 2 compounds at that time from all the ones they screened. One is named quercetin, which has been used in the dietary supplement world my whole career. And I've been a naturopath since 1996. And another was a medication called dasatinib. And what they found is that quercetin was senolytic, which meant it helped, some of these senescent cells go through apoptosis in some tissues. Endothelial cells were one of the areas, but not in others. Like what didn't seem to work in adipose tissue, where our fat cells hang out, where dasatinib was senolytic, but in different tissues. And when you combine both, they were more powerful in terms of helping these animals manage senescent cell burden than either on its own. And so they coined the term senolytic at the time to describe compounds that could help, so to speak, prune away the senescent cells that had accumulated. And since then, in 2015, that idea of senolytic compounds has just exploded. There's now hundreds and hundreds of studies on PubMed that use the term or the concept of senolytics.
So it's basically the senolytic is the tool to prune away that yellow leaf to make sure it doesn't linger.
Yeah, and what they're doing in a sense is they're just convincing that senescent cell to finally go through apoptosis. So fundamentally, to have the yellow leaf finally fall off the plant. And so I think it's just a super cool area. And some of the like one of the things, I've seen a few studies on this recently that I just thought were super cool, and it had to do with organ transplantation. So, when someone needs an organ transplantation, they try to match blood type and other things to make sure that it's a good fit for that person. But often you could be a 25-year-old and get an organ donated from someone that was on the older spectrum before they passed away and donated their organs. So anyways, what they found in these animal studies is when they transplant old organs into young animals, the old organs would have some senescent cells. And so they're fundamentally almost aging that young animal prematurely, because the senescent cells are, now changing the environments, in the whole system.
Throughout the whole body, yeah.
And that in some of these studies, if they've done senolytics in advance to try to, get rid of the yellow leaves from the transplanted organ before giving it to the young animal, then there's a better outcome, right? So that's why when I said, I think 10 years from now, there'll be, that we'll even be more interested, because some of those studies are just so interesting that if that, that application alone would be super cool.
So just, in a preventative measure, so if someone's going to have an organ transplant, to first give the senolytic, that's what you're saying, is that correct?
Well, in the animals, what they would do is they would use the senolytics in the organ that was going to be transplanted into the other.
Okay.
Yeah, right. So, yeah. And so it wouldn't...
directly into, okay, well, that's fascinating. So do you see in the future that application? What other applications do you see in the future?
Well, the original idea that came out of the Mayo and Scripps research was when they gave these senolytic compounds to old mice, that they rejuvenated them. Their fur became healthier, their body composition became more like a young mouse. They had more energy. They just performed much differently than they did. So I think that idea of, and the way I would just think of it is that we know right now I'm 62. And so statistically, someone my age is probably going to live, to mid to late 80s, say 87, just on average. Usually, at least the last third of that isn't great quality of life. It's usually, assisted living or worse, right? So that's just a big picture for, how things are in our society. And my goal has always been, I want to get as close to the end, getting to live Dr. Greg's life, Dr. Greg's way as possible. And so I think, the idea to me of senolytics aren't things that are going to make, me or you live, 10, 20, 30 more years, at least as I currently understand it. They're much more things that may improve our performance, so that we can do more of what's important to us for more of our years. And that's the promise so far that's showing up in these different animal studies, where whether it's the brain, which is a big love of yours and mine, or joints or muscle tissue or fat tissue, that really every system seems like it performs worse when senescent cells are allowed to accumulate over time, and better when we can prune them away.
Wow, that's fascinating. Well, I'm 60 and I'm very pleased that I'm taking these senolytics that we're going to talk about in a minute, because it's the quality of that last third of our life that we want to be able to live in a better way, have more quality. And that, that's also got so many economic implications as well. And, with in every level. So that's really a huge factor, isn't it, to help people.
Yeah, and I was speaking with a naturopathic doctor yesterday. She's done a lot of work in her career with injuries, physical trauma more. And what she mentioned is that an observation she's consistently had over the many years she's worked with patients is that young people will have some kind of like a physical injury, maybe an athletic injury, and bounce back pretty quickly. But there comes a point in most people's lives where they don't, right? They have something that happens, and it almost like the wheels came off, right? It just is hard to get back to where you were. And she said, well, could that be related to senescent cells? And I said, yeah, I would guarantee that there's a role. And that's because of research that's looked at it. And one of the, like as an example, I mentioned that distinction, transient and lingering senescent cells. And so if you had a young, these studies have been done in animals, but say a young animal, an old animal, and did some kind of intense exercise for them that they weren't accustomed to, both would create senescent cells. It would be, in part of the response to that, right? That stress. What they would see in the young ones is a couple days later, they would have largely gone away. They'd have, on their own just disintegrated, or the immune system would have found them. What they would see in the old animal is what they often say is an explosion of senescent cells. So way more would have been made. Mm-hmm. And when they look weeks later, they're still there, causing disruption, right? And so, going back to her observation, maybe it's joints, right? So we know that joint issues become more and more common, starting for many people, say late 30s. And, by, mid 50s, it's just super common and becomes more and more common with each passing few years. And when they've looked at joints in animals, again, if they transplant senescent cells into a young animal's joint, they become the equivalent of arthritic. And part of the reason is it's almost like the senescent cells form a layer over the stem cells and prevent stem cells from regenerating and repairing that tissue. And so, like joints would be one of the areas that senolytics and senescent cells have looked at, because it's such a clear cause and effect.
Wow, that's amazing. Okay, I have a couple of questions around that. Cause and effect. So we want to talk about sort of the time factor involved, how soon, and because that's always a question in people's minds if they start taking senolytics, what is the sort of time frame? And then the human trials. I know that I'd love to know a little bit more about human trials. And then thirdly, just hormones. I mean, it's like, is there some relation to potentially improving hormonal balance as one gets older, that kind of thing? So it's 3 questions.
Yeah, so the way senolytics have been used in animal studies and are being used in the ongoing human studies is usually thought of as hit and run dosing. And what that means is intermittent. So they would give, like the amount of senolytics that they expect to be useful all in a couple of days, so 2 or 3 days, and then wait some duration of time after before they would do senolytics again. So this idea of cycling, having a vacation from it, and another cycle. And human studies, there's only been a few published on senolytics to date. They've also done this. Most have been, more in the what I think of as safety, tolerability studies, or, phase 1, phase 2 studies. At the Qualia brand, we've done our own couple studies on our senolytic blend, which is a blend of 9 different plant senolytic compounds. And what the main area we looked at actually was joint issues. We recruited people that were already struggling with having, discomfort or challenges doing activities of daily living. So, like comfortably walking up and down cars or bending over. Mm-hmm. And what we had them do is 2 days of Qualia senolytic, 12 days not doing anything, 2 more days of Qualia senolytic, 12 days of not doing anything, and 2 more. So really over about 5 weeks. 3 cycles. And what we saw was, on average, big reductions or big improvements in joint performance starting after that second cycle, with then even more after the 3rd cycle. So, in that use case where we're doing it, what I would think is slightly more aggressive, what I do personally more in a preventive sense is I take it once a month. So I'm, like not quite that. I think of that study as a slightly more accelerated, right? You're really doing 2 cycles a month instead of 1, but quickly, right? We saw very profound improvements in a very short amount of weeks. Time.
Mm-hmm. Yeah. Within a few weeks, which is quite amazing. And then so you haven't done direct studies on hormones and senolytics?
No, the other thing we've looked at is a questionnaire called the RAND SF36, which SF stands for short form, 36 is 36 questions, that looks at 8 different areas of basically health. And it's a really commonly used questionnaire for quality of life related to health. And so what we've seen is the subgroup of that's related to energy. We've seen big improvements, again, in that within 3 cycles. We've also there's a area that's called emotional function. But think of it as, is your emotional well-being interfering with you being able to live your life your way? We've seen really profound changes in that as well. And then, of course, the physical comfort scores as well. So, those are the main areas that we've looked at, and we've consistently seen improvements very quickly.
Well,
go ahead.
No, go ahead. No, you go ahead.
I was just going to say hormones, like hormones are, something I've not seen looked at even in the animal studies, and we've not. But hormones, there's biological rhythms to hormones. Some have circadian rhythms, some have monthly rhythms, some have seasonal rhythms. And like steroid hormones, as an example, are produced starting in our mitochondria. So, my guess is anything we're doing to make cells and mitochondria perform better has some indirect benefit to hormones. I wouldn't expect a direct. And what has been seen in animal studies is many of what you think of as the metabolic issues that adipose tissue or fat tissue causes. So your challenges with insulin and in other metabolic things from fat tissue improve somewhat when senolytics are used in animal experiments. So my guess is you'd probably see something, with some hormones, but maybe not all hormones, if that makes sense.
Absolutely. Well, everything's so interlinked and connected in the body and the biochemistry. So one thing's going to definitely carry over. So potentially in the next 10 years, there could be more research in those types of areas too, as they see more areas that are improving, which is going to be super interesting. Okay. So what can people do? So you mentioned that you take senolytics, which is then obviously this, it's something that people can actually take to help get the yellow leaves off the tree. You mentioned that there's the research you did it in a 3 cycles over 6 weeks, and you saw quite dramatic influence. You mentioned you use it monthly. I use it monthly. I've actually got it here. I've got your Qualia senolytic here for optimized aging. So, and you actually supports youthful cellular function. Could you talk about, the specific senolytic that Qualia has produced and the research behind and what it can do and how to use it?
So I mentioned that one of the first two senolytic compounds identified was quercetin, which, at the time I was like, oh, that's cool. Like as a naturopathic doctor, I'd used quercetin, many times over the years. Yeah. And then the next plant compound that I saw identified was, I think, a year later. And it was something called piperlongamine. And piperlongamine is from a plant called Piper longa. So black pepper is from Piper nigra, like the black pepper plant. Long pepper, believe it or not, way back was used as much as black pepper for that spicy type of thing. And it's still widely used as a herbal extract in Ayurvedic medicine, particularly. So black pepper, the common spice, doesn't contain any piperlongum, but long pepper does. And so it's like, okay, well, that plant compound also was senolytic, but in a very different way than quercetin. How it was convincing the yellow leaves to fall off the plant were just different, right? So it's like, well, that probably would be cool to add with quercetin, it would seem. And then about a year or so after that, the same group at Mayo decided, okay, well, quercetin was senolytic. Let's look at some other really commonly used plant compounds, polyphenols specifically, and see if any of those may also be as good or better than quercetin as a senolytic. And so they tested 10 things. Quercetin, again, was one of them. And what they found was a polyphenol called fisetin was even a more powerful senolytic compound than quercetin was. They also discovered that luteolin and curcumin, which are other polyphenols, were senolytic as well. And so they published that. And at the time, I remember some of the longevity experts I follow were like, oh, super cool. Like fisetin looks like it, worked on its own, where quercetin needed to be teamed up with that medication to be as beneficial. So all of a sudden there was like, buzz about, oh, well, like who sells fisetin and where can I get fisetin? And so what then kind of happened over time is that several other plant compounds have been identified as senolytic. And almost going back to that original discovery or insight by the Mayo and Scripps researchers that something can be senolytic, but that doesn't mean it will help manage senescent cells equally in all tissues, right? So that their original thing was they stacked the two things together. I think that was part of the realization for the Qualia senolytic is that, all right, we've got, these different potential compounds, but maybe to get the most benefit, we need to put things together that cover more tissues, right? So, quercetin, we know, isn't going to be particularly useful in adipose tissue, but fisetin looks like it could be there. So that's really what led to the development of Qualia senolytic was just following the research and then trying to do something that supported multiple tissues, and then looking at the same types of mechanisms that were originally studied by the Mayo researchers to see, are there other plant compounds that maybe no one's identified yet that can correct some of these mechanisms that their cells are exploiting to avoid going through apoptosis. And then what we do at the Qualia is once we kind of come up with an idea, we'll then study it. So we before we ever put that box out that you held up, the Qualia Senolytic, we did our own internal studies to see, did it make a difference in people with joint problems? Did it make a difference when we used the SF36 in people, that were in their mid-30s and older? And when the answer was yes, it was like, okay, this is helping people, so we want to make this into a product.
Okay, that's wonderful. That's amazing. And it's actually simple to use. You use it once a month. I'm just going to open it up here, and you take these. It's actually quite a lot of tablets. You take 6 in one night and 6 the next night.
Yeah, that's it.
And then you don't have to.
Yeah, no, go ahead. Sorry.
And then you don't have to take it for another month. So it's very easy to take, and it's doing, so it's one of the other questions I wanted to ask you, the cycling effect. Why did you, I know it's done from research, but is there something to do with, is there a life cycle? What is this? Why do you cycle it? I couldn't get my words out there. Sorry.
Yeah, so the original idea behind the cycling in part had to do with the combination of quercetin, which would be fine to take every day, but dasatinib, which wouldn't be, right? It's a pretty powerful immunomodulator. So at the time, the researchers thought, well, maybe the best risk reward ratio would be to do this intermittently, like try to get more of the upside with less of the downside. And so from the beginning, that idea was baked in. And part of the idea would be we don't want to do something that's disrupting the green healthy leaves, right? We want to leave those alone. And the other reason they thought that would be a useful approach was because if you take hormones as an example, hormones, like thyroid hormone needs to be, hitting receptors, all the time, right, to have an effect. For senescent cells, we just have to disrupt what they're doing to resist apoptosis and finally get them to, on their own, just fall off out of the tissue, so to speak, right? It's not like you have to prune them every day. Like once they're pruned away, then, we're good. And so I think that also is part of the reason behind it. And it makes sense, right? Like why do something every day if, and I guess the analogy would be with pruning. If you pruned a plant every day, you'd kill the poor thing.
Exactly.
Right?
Exactly.
And then the other reason I think that approach is important has to do with something that those researchers didn't think of, but like physiology receptors, so our vision, as an example, is designed on change, but even more specifically, what would be thought of as proportional change. So this analogy I would give is, imagine you go into the darkest closet in your home, and now you light one candle, you'll notice a big difference. But if you went into that same closet and there was 99 candles, lighting one more won't make any difference. You might not even notice it, right? And so quantities aren't that important for receptors. What matters to receptors is they're trying to figure out how the world outside them is changing. And when you give high amounts of these plant compounds bolused into a couple days, that's creating a really big signal for those receptors on the cell to say, oh, something in the world outside me just changed really big. I better shift my behavior. And the pathways that interact with cells resisting apoptosis are nutrient sensing pathways. So I think that change also matters. So I think taking, like, as an example, Qualia Senolytic and saying, oh, well, I don't want to take, all 6 capsules today and 6 tomorrow. I'll just take 1 a day, every day for the next 2 weeks. I wouldn't expect that to work anywhere nearly as well, if, maybe not at all, right? So I think we want to do something that creates this big, big change so that cells will detect that and shift their behavior. And what's shifting in the senescent cells is that I think fundamentally they're like, okay, I was, taking up space, but now, the environment's looking pretty weird. So I'm willing to finally go away and, be recycled and used for something else.
I love that. It's almost like the dark closet example you gave. It's dark and then suddenly there's 91 candles. That's really waking them up. Oh, why is it so bright in here? So that's what your sort of monthly cycle, that makes so much sense, and not to do damage to areas that if daily, certain of the ingredients you can't take daily and that kind of thing. So that's amazing. I know that our listeners have this special for our listeners. There's a code, and so we're going to put that in the show notes. And I'm just very grateful to you for coming on the show and explaining about this product, because I love it. I've been using it for, I think it's probably about 5 months now. I think this will be the 5th or the 6th dose, and I definitely do feel a difference. I am a very healthy person, but there's definitely a difference. And so I'm very excited. And also, now that I understand more about what is really going on, and that's what got me interested in the first place, what's going on. But you've really, highlighted this even more. So I really hope it will help a lot of our listeners to take charge of their last third of their life in a really great way. So thank you so much, Dr. Kelly, for being on the show and for sharing your knowledge. And is there anything else that you'd like to share with my listeners?
No, I would just say the way I think of Qualia Senolytic for people like you and I, right? So, my dad passed away at 68. My
dad was 69.
Yeah. And, he lived his life much differently than I did. My mom's, lived a lot longer. But I want to do, and this has been, a goal of mine going back many, many decades. Like, I want to do what I can that's sound investments so that when I get older in my life, I'll be better off than my dad. And, and I just personally view Qualia Senolytic as one of those investments that I make in myself every month. So, if it makes sense to some of the listeners to also make that investment, then, I invite you to join me.
Fantastic. Well, thank you so much. And all the link and details of how they can get hold of the Qualia Senolytics product will be in the show notes. And thanks for joining us today.
Thank you for having me.